So hello friends, welcome back. This is another question from physics and from the chapter heat. So the question is like this. It is from advanced. More than one is correct. Okay. So the question is like this. There are two cubes of the same dimensions and of the same material. Yeah, there is a cavity, small cavity inside one of the cubes, and the temperature is raised in both of them to some same temperature, and they are out to cool. We have to tell whether the heat loss rate will be same in both of them or different, and after long time temperature of the solid cube will be higher or the hollow cube will be higher. Yeah? So the question is like this. It is not so difficult if you know the basics, if you know all the formulas. It is very easy. But as to decode the question, to form these diagrams, students first of all find difficulty. So first of all, whatever is written in the question, you should form diagrams of that. Okay, that is also one very good practice. That is how you learn. Okay, so now let us see the question. I hope you know the formula of delta Q is how much? Delta Q is sigma A emissivity T1 to the power 4 minus T2 to the power 4. Right? So delta Q upon, and the total heat loss. So this is actually your delta H, heat current, right? And if we talk about delta Q, so it is delta T also here. If we say dQ, then it is dt here. In small time dt, a small dq change. Now if we see dQ upon dt, sigma A emissivity T1 to the power 4 max T2 to the power 4, right? Now both of them at the same temperature, as I told you. T1 is same. T2 is the temperature of surroundings, that is same for both. Sigma and this emissivity is same for both. Talking about area, so heat is in both the question, heat is coming from the surface only. The cavity has no role to play here. Yeah? The cavity is inside. If the cavity was bigger, if the cavity it was so big that just air would pass through this thing, then I should have considered the area inside also, because from there also now heat can escape or heat can come in, right? Then the area would have been different. But in this case, area is same, as the heat is coming from the outer surface only in both the sides. Okay. So the question was cavity is small. If the cavity is big, then the answer will change, because area from which heat can escape will change. So in these cases, you see dQ by dt is same for both. That means heat loss rate is same. It is not different. Okay. Talking about after long, what will be the temperature? Now this dQ, it is mc dt. Delta T upon small dt, temperature time, sigma A emissivity T to the power 4. So you can see dt upon dt is inversely proportional to mass. So if they have same material, I don't have to worry about C, sigma emissivity. Outer area is same, I don't have to worry about this. The temperature of the body and surrounding is same, I don't have to worry about this. So you can see it is inversely proportional to mass. So obviously this has bigger mass, right? So this has bigger mass, that means rate of cooling is slow here, and rate of cooling is fast here. It has less mass, so it will cool faster. So after a long time, this temperature, its temperature will be much lower and its temperature will be much higher. The solid cube will have higher temperature. So answer will be A and C, right? So I hope the question is clear. Simple based on these formulas. It is of advanced, JEE Advanced, and not so difficult, right? So I hope it is clear. If you have any doubts, write in the comments. Share this video with all your friends, and we'll be in the next class with all good questions. And till then, keep practicing. All the best.